Bismillahirrahmanirrahim. Assalamu alaikum. I am Kashiful Khair from PS Chemistry Department and my ID is 018. The topic which was assigned to me for presentation is nuclear reaction and their characteristics. So let's have a look at the presentation layout. Firstly, in this presentation, I'm going to tell you the nuclear reactions. After that, we will study the types of nuclear reaction that include fission and fusion reactions. After that, we will see the radioactivity, and at last, we will discuss the characteristics of nuclear reaction. So let's start with nuclear reaction. A process in which two nuclei or a nucleus and an external subatomic particle collide to produce one or more new nuclides. Basically, it is a reaction that involves the conversion of at least one element into another element. For example, here I quote example of fusion reaction in which two hydrogen molecules are converted into a helium. So it is a example of nuclear reaction. Next is the explanation of nuclear reaction. Basically, nuclear reaction involves a change in the identity or characteristics of an atomic nucleus induced by bombarding it with an energetic particle. Here, the bombarding particle may be an alpha, gamma, or a neutron, or maybe a proton. But keep in mind that bombarding particle must have enough energy to approach the nucleus in the range of strong nuclear force. So, a typical nuclear reaction involves two reacting particles. First is heavy target nucleus and the second one is a light bombarding particle. So when a heavy target nucleus is bombarding with a light bombarding particle, it will be converted into a heavy product nucleus with a light ejected particle with a large amount of energy released. For example, nitrogen with alpha particle is converted into oxygen isotope and a proton. Here, oxygen isotope is a heavy product nuclei and a hydrogen nuclei or a proton is also a byproduct. So, basically it has two types. First is fission reaction and the second one is the fusion reaction. Firstly, we will see what is a fission reaction. Reaction in which large nuclei are broken into smaller ones by the bombardment of low energy neutron is known as a fission reaction. Actually, in nuclear fission, an unstable atom splits into two or more smaller pieces that are more stable and releases energy in the process. Usually, a large amount of energy is released during the fission reactions. Fission reactions often triggers a chain reaction of events. How? Basically, extra neutrons also releases in the fission reactions, which can split additional atom, resulting in a chain reaction. So that releases a lot of energy. I will explain this point by diagram in the upcoming slide. So fission reaction is also known as a radioactive decay. The fission of heavy element is an exothermic reaction and huge amount of energy are released in the process. So nuclear fission occurs with heavier element where the electromagnetic forces pushing the nucleus apart dominates the strong nuclear force holding it together. Next is an example of nuclear fission reaction. So, here we can see that when a nucleus of uranium-235 undergoes fission, it splits into two smaller atoms and at the same time releases neutrons and energy. Some of these neutrons are absorbed by other atoms of uranium-235. In turn, these atoms splits apart, releasing more energy and more neutron, and they start the or continue the process again and again. So, let's have a look at the mechanism. As I talked earlier that fission reactions start with an unstable atom, and in the given example, uranium-235, which is slightly unstable, is bombarded with a low energy neutron and results in producing uranium-236, which is more unstable, and this will go for reaction. And the resulting element will be krypton 94 and barium 139 with the release of 3 neutrons, and a large amount of energy is also released in this process. So as I talked about the instability of the element, the question is why nuclear instability occurs. The answer to this question is slightly conceptual. As we know that in the nucleus there are two different kinds of forces that are present between the particle. First is strong nuclear force, and the second one is the electromagnetic force. Firstly, we will see what is strong nuclear force. Basically, nuclear force is a force present between two or more nucleons. This force binds the protons and neutrons together inside the nucleus, and it is more powerful when the nucleus is small and nucleons are close together. The second force is the electromagnetic force, which is also present that causes the repulsion between like charged protons. So, nuclear force and the electromagnetic force, these two forces will produce opposite effects in the nucleus. Nuclear force acts to hold all the protons and neutrons close together, while electromagnetic force acts to push protons. So, in atom with small nuclei, the strong nuclear force overpowers the electromagnetic force. As the nucleus gets bigger, the electromagnetic force becomes greater than the strong nuclear force. So in these nuclei, it is possible for particles and energy to be ejected from the nucleus. Due to this reason, these nuclei are unstable and their instability results in fission and radiation processes. This is the flow sheet diagram of the fission reaction. We can say that uranium-235 is bombarded with a small neutron and it will be converted into uranium-236, which is more unstable than uranium-235. Uranium-236 produces krypton-89 and barium-144 and also releases 3 neutrons that will further continue or proceed the fission reaction. Here is the flow sheet diagram of the chain reaction. We can see that in the left side, there is a neutron that starts the chain reaction. Fission reaction will start and it will be bombarded with the uranium-235 and will produce krypton and barium and release 3 neutrons. These 3 neutrons will further proceed the fission reaction and further proceed or produce 9 more neutrons that will undergo the other fission reaction. So it is a chain reaction that starts and never ends. Then the second reaction is the fission reaction. Basically, it is a process of fusing two smaller nuclei to form a large nuclei with a large amount of heat. For example, one of the most important fission reaction is the generation of energy by the fusion of two hydrogen atoms to form a helium. So we can see that two hydrogen atoms which are small in the presence of energy give us a helium atom. Energy and neutrons are also released in this process. Fission reaction require high energy to force the two positive charged nuclei close together enough to fuse. So once the nuclei fuse, more energy is released than the required for the reaction. The next is the radioactivity. Radioactivity is the decay or disintegration of the nucleus of an atom. It has basically 3 types. First is alpha particle, which is called as helium nucleus. Second one is the beta particles like high energy electrons, and the third one is the gamma particles like electromagnetic radiations with very shorter wavelength. All of these characteristics and more can be shown by using an equation to describe the radioactive process. So next are the characteristics of nuclear reaction. The first characteristic is the balanced nuclear equation. In nuclear equation, the elements represent only the nuclei of atom rather than the entire neutral atom. So, a balanced equation must have to attain the two given points. Firstly, the total mass of the product must equal to the total mass of the reactant, and the total charge of the reactant must equal to the total charge of the product. Here, the charge of the reactant is the sum of their atomic numbers. So in a balanced nuclear equation, there are superscript and subscript. Superscript shows the mass of particles and the subscript shows the charge of the particles. So here I quote an example. Consider the equation for the decay of radium-226 to radon-222 with the simultaneously loss of an alpha particle and energy in the form of a gamma rays. So radium 226 is the reactant, radon, alpha particle, and a gamma ray are the product, and the equation is shown in the figure. So, a nuclear equation is balanced with respect to mass and charge. So, firstly, we will see how the nuclear equation is balanced with respect to mass. In the equation, we can see that the sum of the masses of the reactant 226 equal to the sum of the masses of the product, because radon has 222 and alpha particle have 4. So when we combine them, it will be equal to the sum of the reactant. So sum of the reactant and the sum of the products are equal. We can see that this equation, this nuclear equation, is balanced with respect to mass. Now we will check how how the nuclear equation is balanced with respect to charge. In the given example, we can see that the sum of the atomic number of the reactant 88, radium has atomic number of 88 equal to the sum of the atomic number of the product. Radon has 86 and alpha particle have 2, so when we combine them, it will equal to the sum of the atomic number of the reactant. So the energy change accompanying the reaction is shown by the release of gamma rays. So we can see that the nuclear equation is also balanced with respect to charge. So here I quote an example to identify the product in the nuclear equation. The reactions of an alpha particle with magnesium 25 produces a proton and a nuclide of another element. We have to identify the new nuclide produced. The nuclear reaction can be written as follows, where A is the mass number, Z is the atomic number of new nuclide, which we state as an X. So, if atomic numbers and mass number of all but one of the particle in a nuclear reaction is known, we can identify the product nuclide from balancing the equation. So in this equation, we can see that the sum of the mass number of the reactant must equal to the sum of the mass number of the proton. So magnesium has a mass number of 25 and helium has 4, where X is the unknown element and we don't know what is the element is, and A we will written as and 1 from helium. So this will be equal to 28. Similarly, the charges must balance. So we can charge the balance as I written. So then after balancing the charge, we will check the periodic table, and the element with nuclear charge plus 13 is aluminium. Thus the product is 28 aluminium 13, where 28 is the mass number and 13 is the charge number. So we can identify the product in nuclear equation by using this method. The second characteristic is the half-life. In nuclear reaction, half-life playing a very important role in determining the time to use the radioactive material, because they need to be active long to treat the condition. So a radioactive sample is safe when its radioactivity has dropped below the detection limits and it occurs at 10 half-lives or so on. So half-life is defined as the length of time required for half of the sample to decay. The rate of decay of radioactive isotope, which is also called as radioisotope, is measured in terms of its half-life. For example, iodine 131 has a half-life of 8.1 days. If we start today with a 25 milligram sample of iodine 131, after 8.1 days the sample will contain only 12.5 milligram iodine 131. At the end of the 16.2 days, the sample will contain only 6.25 milligram of iodine 131 and so on. The matter in the sample doesn't disappear, it changes to another element, the product of the radioactive decay of iodine 131. So, in the figure, we can see that it is the rate of decay of iodine 131 as a function of time. So, we can see that in the first half-life, The atom of radioisotope remaining in milligram is 12.5. After second, it is 6.2. After third, it is 3.1. Fourth, it is 1.6. And after fifth half life, it is approximately 0.8 milligram. So this is the half life chart of iodine 131. Then there are also other characteristics of nuclear reactions. So, a nuclear reaction involves a change in an atom's nucleus, usually producing a different element. Different isotopes have different behavior in nuclear reactions. The energy changes in nuclear reactions are more than any other chemical reaction. For example, nuclear transformation of 1.0 gram of uranium 235 releases more than 1 million times as much energy as the chemical combustion of 1.0 gram of methane. So, nuclear reaction involves the emission of alpha, beta, and gamma particles from the nucleus. Nuclear reactions are unaffected by temperature changes. And the last one is nuclear reaction is balanced in terms of both mass and energy. Nuclear reactions are balanced in terms of both mass and energy means in nuclear reaction mass is not conserved. One of the mass is converted into energy and this energy is called binding energy and the binding energy holds the nucleons together. So thank you, that's all from my side.